good. Okay, so you're looking at the one with the chart on the front. And here we go. Okay, so look at the graph. What is it a graph of? Okay, it is a graph of g prime, which is the derivative of g of x. Okay, now, question. Do I know what the graph of g looks like? No. All we have is the graph of the derivative of g. So we're going to make assumptions about the graph that we can't see based on the graph that we have, which is g prime. So look at part A. On what interval is the function g, you can go ahead and write it in, increasing and decreasing? Okay, we'll think about if I want g to be increasing, what do I need g prime to be? Positive or greater than 0, or in the graph, what would I be looking for? Above. So, I'm going to put dots on my critical numbers. So my critical numbers are when g prime of x equals 0 or where it's undefined. And I can see that that happens at 2 and at 5. So 2 and 5 are my critical numbers. Then I'm going to look for where my graph is above and below. I'm going to assign positives and negatives to each subinterval based on that. So for the beginning of the interval, my graph is up here. Is it positive or negative? Positive. When does it turn positive again? After 5, so positive out here. Okay, then in the middle, what's my sign? Okay, and here my sign is negative because it's below. So that tells me that my graph of g that I do not have a picture of was increasing, decreasing, increasing. So to answer question A, on what interval is g increasing for? Okay, negative infinity to 2, union, 5 to infinity. Now, somebody in the other class was like, why don't I have to stop the number line at 0? Okay, if it says on a closed interval, stop, don't go to infinity. But if it doesn't say you can go to infinity, no big deal. Okay, so I would put increasing because g prime of x greater than 0. And then in your mind, you know that what that means is that my graph is above the x-axis. So I'm going to put that here, above the x-axis. Now, where will my graph be decreasing? Because it asks me to list both. Okay, very good. Decreasing will be where it's below or a negative sign, which is between 2 and 5. Because g prime of x less than 0.
What was the scenario? Was like less than or equal to?
That's if you're trying to like say it does like a bounce and you don't want to split it up into 2 parts. I'll show you after we finish if you want. Hold that thought. Okay, so then it says, where do I have a relative max? Well, look at your number line. Where's the max? Max. 2. And where's the min? 5. Anna, were you gone yesterday? You need this, huh? So sorry. Okay, so write on your thing. Your max occurs at 2 because g prime changes from positive to negative. Okay, so write that in for your answer for part B. So I have a relative max at x equals 2 because g prime changes positive to negative. Now, also keep in mind, okay, that when you take your quiz, you get to use your notes. So even though it's annoying, you'll have every answer pretty much for if you get a graph on this paper, and then you get to use it. Okay?
So we should all be in hundreds.
Should be. Okay, so next I want a relative min. Where does the min occur on my number line? At 5. So I have a relative min at x equals 5 because g prime changes negative to positive. Okay, the other thing that we talked about yesterday is that if you have a graph of g prime, remember that g double prime stands for the slope of that graph. So I'm going to write that up here at the top. For concavity, g double prime of x is the slope of g prime graph. Okay, now think about that. That should make sense. G double prime's the derivative of g prime. Well, then if I'm looking at g prime's graph, I'm going to be looking for the slope. So mark an X just like we did yesterday on your paper where the slope changes sign. There's only one spot. What's my slope here? Negative, then what? Negative, then what? Where did it change? Put an X at 4. So I'm going to do a second derivative test here. Now notice, this is going to make it easier for you in the future. Okay, try and line up these two derivative tests. So when I put 4 on my number line, I'm going to try to line it up between 2 and 5. Okay, because at the end we're going to have to put our derivative test together to do a sketch. And it'll just make it easier. Okay, so there's 4. What did we say the slope was on this side? On this side? Negative slope. What's the slope on this side? Positive. And remember, that stands for g double prime, which tells me about g's concavity. So it's concave down, concave up. Okay, now I'm realizing that when I did this number line here, I forgot to label it. So I'm going to put a g prime on the bottom.
Will you take off points?
Usually on the AP test they don't take off points for that, so I probably won't, but there have been a few years that they have taken off if you didn't label it. Only a couple, but it's just not worth it to miss, because you don't feel like putting it. It's one letter, you know?
So like, I don't have to use a number line, right?
You do.
I don't know, guys, I feel like after learning what I like yesterday's stuff, I don't need to.
Okay. Then don't put it and see what happens.
So you're gonna miss points for number line.
Yep. Okay, so where's it concave up? Look at our number line that we drew. 4 till infinity. Could you put x greater than 4? Sure. Doesn't matter. Okay, they're the same thing. Where is it concave down? Negative infinity to 4, or you could put x less than 4. Okay, again, doesn't matter. Then when it says justify, here's your justify. Because g double prime, the slope of g prime, is less than 0. Now, how would I adjust that response for concave up? Yeah, you just change it to a greater than. So I'm going to highlight the becauses, okay, because tomorrow or on Tuesday, okay, it might make it easier, maybe underline it so that you remember. That's because of this justify right here. Explain is the same thing. Okay, one more like that, point of inflection, where does it occur? At 4, because what happens at 4? Okay, at x equals 4 because g double prime of x, slope of g prime, changes sign. Okay, and whenever g double prime changes sign, I have a change in concavity, but I don't have that graph, so I'm just stating that that's how I know. Okay, look at letter G. Suppose g of 1 is 4. Use a tangent line approximation at 1 to estimate the value of g of 1.2. So remember, when you're doing this guy, number 1, you're going to write the equation of the tangent line. And then step number 2, you're going to plug in the decimal that they gave you. Okay, so we haven't done one of these in a while, but they do these a lot on this type of question. Now, what 2 ingredients do I need to write the equation of a tangent line? Point and a slope. For the point, okay, yes or no, think about the question carefully. Can I use the graph of g prime for the point? No, because what is it? G prime. That's not a point. Where is the point? They just gave it to you right there. That's your point. Remember that for a point, I need regular g. So if g of 1 is 4, what ordered pair is that? 1, 4. Because I need regular g to give me a point. Now, when I want the slope, I'm going to want g prime of 1, and that's what I have in my graph. So this is where I'm going to use the graph. Because what's the graph of? G prime. So if I want g prime of 1, look at your graph. At 1, what is the value of g prime? 1. Okay, so I'm going to come up here and label it. Okay, g prime of 1, I'm coming up here. G prime of 1 is 1. Okay, because that's the graph I'm looking at is g prime.
So how would we find it if we weren't given the graph?
They'd have to give you an equation. You'd take the derivative, plug it in. You'll also learn soon how to take derivatives in the calculator. You can do it like that.
This is like review from what we learned.
Yeah, so we're kind of tying something we already know how to do with if they give you a graph. Okay? So from here, my slope we said is 1. Let's write the equation. So it'll be y minus 4, 1x minus 1. Then what decimal are we plugging in? F of 1.2. And we're plugging it in here. What is 1.2 minus 1? Okay, 0.2 times 1 is 0.2. What do we do with the minus 4? Plus it across 4.2. Okay, now, real quick. We talked about this like maybe earlier in the week, but we didn't talk about it a bunch. Let's see if you remember. Draw for me a graph that is concave up. We're going to do it down here in this space. So let's say that G is concave up. Look at the second part of the question that they asked you here. They said, is your estimation 4.2? Is it over or under the actual value? Remember that concavity is what helps you answer this. On your concave up graph, draw a tangent line. Where is it compared to the function? Is it too big or too small? Is it above or below? Okay, where is the line? The line is below. So if G is concave up, then tangent line is an underestimate of the curve. Okay, if your tangent line is below the curve, that means it is underestimating where your actual little u graph is. Okay, now let's flip it and say our graph is concave down. So let's say that G is CCD, concave down. Draw a little concave down graph. Whoop, there it is. Okay, then draw a little tangent line on it wherever you want. And no matter where you draw your tangent line, what should you notice about it compared to where the graph is? Okay, say I put it on this side this time. Where's my tangent line? It's above. So a tangent line on a concave down graph is an overestimate because my tangent line cuts above where the graph is. So I would put tan line is above actual g of x graph. So it's an overestimate. Okay, so write that down. And you should have that in your notes from maybe like 2 days ago or something, maybe Tuesday. But we barely covered it. So, what I need to know to finish out part G, look at the question. It says, is your estimation the tangent line over or under? I need to know concavity. Okay, so I need to know what G double prime is. Okay, well, what is G double prime in the graph of G prime? It's the slope. So go back to your graph. At 1, what is the value of the slope at G double prime? What would it be? Don't care about the number, just the sign. Look at our 1 right here. Look at the slope. Is that a positive slope? No, it's a negative slope, right? So what I'm going to put here, back in my graph, is that G double prime of 1 is negative 1. Why is it negative? Because look at your rise over run. I'd go down 1 over 1, down 1 over 1. This graph is downhill. That means that my slope, G double prime, is negative 1. Does that make sense?
Yeah.
This is G prime, G double prime is the slope. So let's come down here. We're going to put, we need a G double prime, but now we know that it's negative 1. What does that tell me about G? Is it concave up or concave down?
Concave down.
G double prime is negative, that means it's concave down. Then where's my tangent line going to be? Above, an overestimate. Very good. So now, if it says explain, this is what you would say. Okay, G is concave down around x equals 1. So, tangent line is above the curve. Therefore, overestimate.
Can I put ST?
Sure. Okay, so G is concave down around the point that I looked at. So that means my tangent line is going to be above my graph, therefore it has to be an overestimate. Now, real quick, someone from the other class said, well, we already knew it was concave down. Look at your number line here. Technically, if we had thought about that, 1 is on this side. What's the concavity? Down. You already kind of knew that from your line test that you did, right? Okay, last thing that we're going to do for part F, yes?
Is that why we like that?
It'll always be up or down. Yeah, I mean, if you made a second derivative test, you could just peek at it and see. Or you can look at that specific point in the graph and just look at if the slope's up or down.
So for F, like find G double prime over
Uh-huh.
3, it'd be negative 1, and positive 1.
Well, okay, let's see. So for G double prime of 2, okay, make sure you're thinking it all the way through. What did we say G double prime is? It's the slope of G prime at x equals 2. That's what G double prime would be. So go to your graph at 2. What did we say the slope is of that little piece of the line segment? We just did it? No, it's not flat. Negative 1, right? We're just counting the rise over run. So one more time, I'll come back up here for you if you need to see it. Okay, if I pick a pretty point, down 1 over 1, down 1 over 1, my slope is negative 1. What is the next point where I need the slope at? 3. Okay, look at 3 on your graph. So I put G double prime of 3 is the slope of G prime at 3. So come up to your graph at 3. Is the slope negative 1? On this side is the slope negative 1? Yeah, but what about on this side? Not the same. Can you tell the slope of a line at a corner? No, so what should you put? DNE. Okay, and then I'm going to put because G prime has a corner. Now remember, the word for that when you can't take the derivative is not differentiable. When is it not differentiable? At corners or cusps. Okay? Last one, I want G double prime at 5. Okay, well G double prime at 5 is going to be the slope of the graph at 5. Now you'll notice that 5, okay, I'm going to come up to my graph here in a second. We're looking for G double prime of 5. Okay, you'll notice that I need to just pick 2 pretty points, count the slope. So if I pick this pretty point and this pretty point, what's the rise over run? Rise, 3, run, 1. Then what's the slope? 3. So G double prime of 5 is 3, and I just count the rise over run. Now make sure, and McDaniel is the one that always called them pretty points. Okay, but don't pick a point that's like in the middle, or you're going to end up estimating, but it won't be correct. Okay, good? All right. Pretty points. Okay, the last thing we were going to do is sketch, but I don't think we're going to have time to do that and the next question, so we're going to move on. So turn to the last page on here that we haven't done, which is the very next page. Okay, so here are your options for the AP test. Here's what's going to happen if they give you questions. If they give you an equation, you'll do what we did Monday, Tuesday, last week. You'll take the derivative, do a first derivative test. If they give you a graph, you're going to do it like this. If they give you a equation on the calculator portion of the exam, you are going to take the derivative yourself. And then you are going to graph it on the calculator. Okay, and the skills that you will need to know how to do, we're going to go over them right now, but you need to be able to find zeros, and you need to be able to find mins and maxes. Okay, so it's not like these are super hard skills you're going to have to know how to do. You should have learned them all the way back in Algebra 1. And then again in Algebra 2, hopefully again in Pre-Cal. But we're going to review them right now. No big deal if you don't remember. So the first thing I need you to do is, they gave me f, I need f prime. What do I need to do on that equation before I can take the derivative? A rewrite. What rewrite am I going to use?
2x plus 6.
Okay, I'm going to take my 2x plus 6 here in the middle. I'm going to put it to the half power minus cosine x. So that's my RW. Okay, so we're going to take the derivative by hand, then we're going to graph it in our calculator. So f prime of x equals, okay, on the 2x plus 6 to the half, what is the derivative of that? Okay, 1/2 moves down. Core stays the same. And then 1/2 take away 1 is minus 1/2. Okay, times chain rule. What's the derivative of the middle?
2.
2. Okay, then what's the derivative of minus cosine? Snow cone, snow cone.
Sine.
Positive sign, good. Now, I could type it in just like that, or I can notice what's going to happen with the half and the 2.
It's going to turn to 1.
Just cancel them out. Now, if I'm typing into the calculator, I think it's easier to leave it like that. So I'm not going to change it into a square root on the bottom. I'm going to leave it just like that. So y equals, in your calculator, 2x plus 6 minus 1/2 plus sine x. Now, the other thing I want to point out to you is they gave you a specific domain. When are we looking at this graph?
0 to 8.
On 0 to 8. And do y'all know how to change that?
Yeah.
Okay. So if you don't, yeah, go into window, and you're just going to adjust your x-min and your x-max to be 0 and 8. Okay? Also, if your graph looks super weird, you might be in degree mode. It should auto reset to radian mode. But if it doesn't, okay, then you can do that. So type it in, 0 to 8, and then sketch the graph on your paper. You can do it. Wake up. Anybody else need a calculator? So we have 2x plus 6 to the power of negative 1/2. Okay, then plus sine x. Okay? Then the second thing I'm going to do is go into window here, and I'm going to make it 0 to 8. So just make yours look like that. So you type it in, type in the domain, and then push graph, then sketch it on your paper. Nikki, do you need a calculator? Can't see. Whoa.
Why is this so tall?
Probably because my other class made it 40 to 40. Yeah, go into window, and then just make your one in. Oh, wait. I think you're in the wrong mode. Yeah, y'all look, this is what it looks like if it's in degree mode. Okay, if you hit mode here, do you see how his has degree highlighted?
Yeah.
Look how messed up his graph is. Okay, it just looks like nothing's there. So all you have to do is hit mode and then switch it back to radian, and then it should look normal.
Mine's not really big.
Okay.
But it's because I zoomed in, right?
That's fine. Okay, so sketch the graph on your paper. Okay, so my graph goes uphill, downhill, uphill. So I'm putting that right here on my paper. Okay, and I would draw it kind of big. Okay, and then here's 8. Notice it gave me a closed interval, so I'm going to cut my graph off on the sides. I am not going to infinity. I'm only looking 0 to 8. Okay, first question says find all critical numbers for the function, then identify as a relative max, min, or neither. So first thing I want you to do is on your paper, put dots where the maxes and mins are, and then label each one as whichever one it is. So where should you be putting your dots? On the x-axis, on the zeros. Okay, so I'm putting one here, I'm putting one here. What type is this one? Max, because how does the sign change around it? Okay, that makes it a max. Okay, then for the second little zero, it goes from below to above, negative to positive. That makes it a min. Now, how am I going to find those? Well, you only need 2 calculator skills. Am I finding zeros or mins and maxes if this is the graph?
Zeros.
Zeros. Remember, I'm not looking at f, I'm looking at f prime. So these are zeros for the graph of g prime. Actually, I'm going to label that on here. Okay, so I'll show you how to do that if you don't know how. So in the calculator, to find zeros, okay, you are going to push second trace. So second here, trace here. And then you're going to go down to the option that says 0. Now, I'm going to show you a little trick that some of you probably know, some of you might not. You have 2 choices when you're choosing the zeros. You can do the little arrows forever. If you like that, fine. But you can also just find the whole numbers that's between and type them in. So, for example, look at this value right here. 1, 2, 3, 4. It looks like it happens between 3 and 4, right? So I can type in 3 as my left bound, 4 as my right bound, and then I don't have to do all the little arrows. Okay, then for guess, I just skip it. X is 3.4243. So, this is x equals 3.4243. Okay, so let's do the other one. Second trace, or second calc, go down to 0. Which whole numbers does it look like this other guy over here hits between? Okay, it's like 5 point something, so I'm going to go between 5 and 7. That's perfect. So, second trace, my left bound is 5. My right bound is 7. I see that it does cross between these little bars it puts in. Push enter to get through guess. 6.045 is my second one. 6.0458. Okay? Alright, so let's answer the questions for part A and part B. We should have enough information to do both of those. So the first one says to identify maxes and mins. We already did it. So I have a local max at x equals 3.4243 because f prime changes plus to minus. And then I have a local min at x equals 6.0458. I'm going to put because ... Okay, you get the idea. We've done like 1,000 of them. Okay, for increasing and decreasing, what am I looking for in my graph? I need it to be where? Above. So, where on the graph am I above the x-axis? 0 to 3, and then from 6-ish to 8. So when I list my intervals for increasing, those are the ones I'm going to put. So 0 to 3.4243, union, and then 6.0458 till 8. Because f prime of x greater than 0. Now for decreasing, I need my graph to be below the x-axis. Where is it below the x-axis? 3.4243 to 6.0458. Because f prime of x less than 0. Make sense? So you're just basically making your own graph, but you're answering the questions in the same way that we were on the other question. Okay, now when I want points of inflection, mark them on your graph. How will you find points of inflection if you're looking at G prime? You're looking for the slopes to change direction. So how many of them are there? You're right, what you said is right. There are 3. There's one here. There's one here, and actually, I don't know. I think I bent my graph, but really it looks like it's kind of flat still. So I'm going to not put one there. Okay, they wouldn't do that to you right at an endpoint. I think I curved mine a little more than the real graph. Okay, so how are we going to find those on the calculator? We already found zeros. We're finding mins and maxes. What am I going to call this top POI? A max. And this one, you'll use second trace and then find the min. Now, that method that I just showed you still works. So, second trace. I'm going to find the max first. And then I'm just going to estimate about what number it's close to. So it looks like it happens between 1 and 2. So for my left bound, I'm going to put 1. My right bound, I'm going to put 2.
Where did you just enter it?
So I did second trace. I went to option max. And then for left bound, I just typed in 1 and 2. Now, if you want to do the little clickety-clickety arrow thing, that's totally fine. It'll still work. Okay, guess. Nobody cares about that. Okay, my point of inflection is at 1.5341. Okay, x equals 1.5341. No, you should go to 4 and then cut it off. Okay, my other one down here I need to find. What will I type into the calculator? Second trace what? Min. So second trace, minimum option is number 3. And then I estimate it looks like it happens between 1, 2, 3, 4, and 6. So I'm going to do 4 as my left bound, 6 as my right bound. Or clickety click 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 until you get it in the middle. Okay, skip the guess. I got 4.7288. So my answer for letter C is going to be that I have POIs at x equals 1.5341 and 4.7288 because f double prime, the slope of f prime, changes sign. And remember, for a point of inflection, it doesn't matter which direction it changes sign. When I have those tops and bottoms, that's where my slope is changing. Okay? Last question, letter D. How do you find absolute extrema?
First derivative plus
Yep, you need the called a candidates chart. Okay, so what go in the candidates chart? What types of things? Okay, so end points. That would be 0 and 8. And then critical numbers. What were my 2 critical numbers?
3.48.
Yep. These guys from up here. Remember, we don't want the points of inflection. We want the critical numbers from part A. So 3.4243 and 6.0458. Now, where did we say we plug into for a candidates chart? F of x. Okay, so I think I already showed you this, but I'm going to show you one more trick. So we don't need the graph anymore. Go into y equals. You're going to change it back to the original, which was square root 2x plus 6. Okay, then minus cosine x. And then if I want to type those in, 0 and 8, I can pull from the table because they're whole numbers. Okay, so at 0, what's my value? 1.4495. At 8, do you see it's 4.8 down here? Okay, so I'm going to record those two. So 1.4495, and then 8 is 4.8359. Those two, I was able to use the table because they're whole numbers. But for the ones that are not whole numbers, I'm going to show you a shortcut. Look up when you're ready, and I'll show you. Okay, if I want to plug in these other decimals, just go into your regular calculator screen, push alpha trace, go into Y1, and then just type in the decimal you want to plug in. And it'll do it for you. Then alpha trace, Y1, I want to plug in 6.0458. And it'll plug it in for you. Now, some of you guys know how to change the table to ask mode and stuff. That's fine too. Doesn't matter. Do it how you want. Okay. So I'm going to write those two numbers into my table. Then which one out of all of them is the absolute max? 4.8, right? Because I got to include my endpoints as well. And then which one's the absolute min? 1.44. So my max was at this endpoint, my absolute min was at this endpoint. But remember, you have to plug into the original equation for a candidate's chart. So just make sure you change your y equals or your numbers will come out wrong. It should say that. Back to the original. Okay? So we're putting them down. It was 4.5447 and then 3.2814. Okay, and then I'm just going to label them on the table. Okay, this is my absolute max, and this is my absolute min.
What was point of label on the table?
On the actual AP test, I wouldn't do that. I'd put absolute max is 4.83, blah, 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 at x equals 8. Okay? Good job. On your way out, I need your calculator put back, and then if you have homework 2, it's due today. If you turn it in on Monday, it's just for a 90. Homework 3 is not due till next Friday. Okay?